Hello and welcome to another episode of the Oxford MAT Livestream. Welcome back. Good to see you again, people in chat. Good to see you. Starting a minute late because I forgot how to do this, and chat was being weird, having some Slido issue for the world. Having some Slido issue. Then I read, oh dear, let's have a look at Slido. At time of recording, at time of being live. It's a very exciting afternoon for me because I've just been on Numberphile. My first ever Numberphile video is out, so that's very exciting. Let us know in chat if you're here from Numberphile. Is anyone like clicking on Numberphile videos and then going through to live streams from there? You can join live chat over at slido.com/matlive. And there is some chat at the moment about how my first ever Numberphile video, I was very, very nervous and I made multiple errors. Some of the errors made it into the final video, so that's fun. And there's some chat about striking, because I wasn't here last week. Some of you noticed that I wasn't here last week. I guess thanks for noticing. Not Gauss wants to know about positive action. I think there's some progress in the sector. I'm not sure that my particular strike action has achieved. I'm not going to say that my strike action has achieved. But everything's better now. Well done me. We'll go though. Okay, people in chat doing unlucky hard at exam players 970912 MJ23. I know you. Yeah, okay. You're going to retake your AS level, you say, because no, I've misunderstood. Okay, you did a hard paper and you didn't get the grade you wanted, but you're going to take it again. Okay, sounds like a plan. Azure is here live. Hi Azure, nice to see you. Good, okay. Delegate, it is not something you should be worried about. It's something that sometimes happens, and I can't discuss individual cases, but it is not something that you should be worried about. Okay, 2021, let's do the poll that we do at the start. Oh my goodness, it's been so long. How do I do this? I always want to know how your day was today. I'm having a 5-star day because I got to go on Numberphile today. Well, I got recorded for Numberphile ages ago, but the video came out today, so you got to see it. Loads of people voting 1 star straight away. That's not what I want to see, but oh, look at that. It's a proper more and more people voting 1 star. I'm really sorry. What's going on? What's going on, chat? What's the matter? There's multiple people there. 1 star straight away. Do you want to let me know? What's on your minds, chat? I'm like genuinely concerned. Like still like, what is that? 5 or 6? Immediate. Oh, one person's now leaving chat because they realise we're going to talk about paper 2021. In fact, we're only talking about the 2021 paper today. On the more recent papers, I want to put the full 2 hours into that so we get to cover more of the questions. Yeah. Oh, too little sleep, says one person in chat. Sorry about that. And somebody else says strep throat in the thing. I'm really sorry to hear. Okay. So illness and sleep we can hopefully fix with sleep, and I hope you both recover and get some sleep as well. Okay. The 5-star people. I've never seen the distribution like this before. Look back. Nav is not a fan of question 7. I don't know if Nav's suggesting that's why Nav's having a 1-star day, but you know. Other people are ill. Yeah, there's something going around at the moment in Oxford as well. People have been ill. If it makes you feel happier about missing a live stream last week, I was not very well last week. So it would have been quite a sneezy live stream. Elru is referring to different projects that I run. There we go. Good. Okay, I now run so many projects. I've got things going on in different places. It's really good fun seeing people come from different places. And people requesting the 2019 and 2020 papers. I sort of have good news that I've covered the 2019 and 2020 papers. Oh my goodness, what is going on there? I've covered the 2019 and 2020 papers quite a lot of times. So if you really want to see 2019 or 2020, we've got, so for example, last year's stream has some videos on those. If you want to see that kind of live stream experience, there's even, or the year before has got those as well. We also have these like 2-hour videos on every question. So if you want to see the answers to every single question from these 2 papers, there are videos on this channel. Easiest way to find them actually is to go to the kind of channel icon. Click on the channel icon anyway, you can see it, and then scroll down, because on the channel page there's a kind of playlist of all of the things. Someone in chat points out that I am actively undermining my own strike. You know, no one's going to write to the Vice Chancellor and be like, I was affected by this strike, I had to watch a recording. I thought about, this would have been too much to remove the recordings, right? No, yeah, nobody would like that. There's also 10-minute videos, but you should not watch those. I mean, you can if you like, but we kind of made the 10-minute videos partly for test takers, partly for a wider audience to show what sort of maths we're up to, not really as a revision tool. Okay. And Quinn 6 last week. Yeah, so I've been on Twitch for a week, which is a sort of weird art project. Everyone in my life was very concerned about me, but I decided to live stream for an entire week. So I now understand Galois theory, so that's a good plus. That's how my week's been. It was good. We went there. We were using some lecture notes that were quite hard to follow, but that's quite an authentic university experience, I think, that we had some stuff that was really tough to follow. I think people wouldn't have liked it if it had been straightforward. There's a uni student in chat who did the MAT paper. You're not banned from saying the solutions. I think that'll be boring for you. If you want to help out people by saying helpful things in chat, and this goes for everyone actually, if you want to help out other people on a question you've done, then that's definitely allowed. If you're a uni student and you want to learn Galois theory, then you might like, no, don't. As an art project, I live streamed an entire week of my life. Right, Jeep wants tips on not panicking. That's a really good question. Especially in question 1, which might be the first thing you look at. So this is a really good question. I personally think that you want to get something done. Maybe question 1A. So maybe your strategy, you go into the exam, the questions are on the screen in 2023, so you load up question 1A, you have a look at question 21A, question A, to see what it says, and maybe just try and have a go at it, and just select something. Maybe don't tick it yet on the answer sheet, but maybe just think, okay, I've done a little bit of maths and I'm going to guess that option. And even if it's a guess, because I think part of your brain wants to feel like you've done something and achieved something, and then moved on. So then you can move on and try other things, and you're going to come back to it, perhaps, if you made a guess. Of course, if you get the correct answer, then you're genuinely confident in yourself, right? But there's I think a bit of that, of trying to just double guess yourself, or almost like get the ball rolling, because I think, and I have this with interviews as well, I think the kind of nervousness or anticipation you have before you start something like that, it is much worse than the experience once you're actually in it. So make sure that you, as soon as possible, feel like you're in it. Okay, now I can put chat here. What am I doing? When I was 18, how much do I think I'd get on the MAT? I don't know. I have looked back at that year. MAT 2000, oh gosh. I'd have done a MAT paper ages ago, and I might have. I've looked at those questions, so I now know that I can do them, but very hard to say. Question in chat, last part of question 6, absolutely brutal. What did I think of it? That's a good question. I can't remember what the last part was for question 6. Oh, this thing. Yeah, no, I found this extremely difficult as well. This makes me think that if I was doing MAT aged 18 and I was applying for maths and computer science, then MAT might not have gone that well for me. Request in chat for me to do the 2023 paper and 24, is integrating e to the x on the MAT syllabus. Here's the thing. I think it's okay for me to ask you to integrate e to the x. I can justify it, right? You know that integration is the opposite of differentiation, loosely. And you know that the derivative of e to the x is e to the x. So I think you can sort of work out this fact based on what you know about integration and differentiation. You know that you're looking for something that differentiates to e to the x. What is that? Oh, it's e to the x. And while that's not explicitly on the syllabus, I think I'd expect anybody doing this exam to be able to work it out. I would, I think, not expect, would I expect this? This one's a bit harder because you have to think, oh, it's like e to the 2x, except it's not e to the 2x, because that would give me 2 e to the 2x. Because you know how to differentiate e to the kx. So then you can fix that by like dividing both sides by 2, but that's now like 3 steps of work, so I feel a little bit worse about setting that. Have I set that? It's doing well on SMC. Right, let's put chat back on screen. Chat's been very chatty, which is good. I'm going to make a quick note of things that people want to talk about off the poll. I found I've got to write it down. Maybe this question 5 has won the vote, but 1J is in there, and 2, which is my favourite. 1C, 1D, 1G. Loads of question 1. Maybe that's the general feeling. I haven't added together the votes, but maybe people genuinely feel that question 1 is where we need to look. That's actually not a super high number of votes. If you're watching live, I can see on YouTube there are people watching live. Slido, you can be anonymous on Slido, you can join in on Slido, and you get to vote on stuff. Yes, that was enough to convince 2 people to vote for question 5 immediately. Right, okay. 2 seconds, let me just go over here and do that. There it is. Right, good. Okay, there was a minute there where someone voted, and they voted for question 5 as well. I think we're going to talk about question 5. And I can't remember what SMC is. Is it the UKMT thing? It's quite different. Oh, it's the triangles. We mentioned these a couple of weeks ago. Here are some triangles. Good. Okay. How do I want to do this? So I think I want the question up. That's a good start. I think we should read the question together. And I think we should, now that we're getting better at math questions together, right? I think that rather than going through every step of the question, every step of the way, I think we should try the bigger picture things. That kind of skill where you look at everything. Oh, it is the senior maths challenge. Okay. And it was on Tuesday, someone says, maybe? Or maybe they're talking about a different UKMT thing. Just to pull out a question from chat, by the way. Hey, see, this is the kind of multitasking we're going to do. We've got a question on the left. There we go, question on the left, chat on the right. Good. Down here, if your method to solve questions is valid but uses concept not a math syllabus, probably fine. If you're following the instructions in the question, then it's probably okay, and you should probably get credit. Particular, good. Okay. Scary Maths Club. Is that what? I'm not sure that's what other people mean by SMC. Okay, I'm going to do it like that. I'm going to read out the question. I hope it's large enough on the screen. I realise I haven't full screened this. And thus, slightly more space. There we go. Slightly better. It's a very strange job, this. Here we go. Okay, we've got chat going that way. We've got question going that way. I think we do quite well on TikTok, right? Because we've got so much stuff going on that on TikTok you could just look at it anywhere and have something grabbing your attention at any moment. I can't do TikTok. It's too distracting for me. Right, let's talk about the question. Timestamp, question 5. Okay, so a triangular triple is 3 positive integers such that we can construct a triangle with sides of those lengths. That means that the sum of any 2 of the numbers is strictly greater than the third. So then it's equivalent to requiring this. Not obvious so far that's actually what it's equivalent to. But if I think about it, then I suppose B plus C is clearly greater than A in this situation. And A plus C is clearly greater than C, which would be greater than B. Okay. So the other ones around sum of any 2, the other combinations are fine. Okay. So we just need to check that once you put them in order, then check that A plus B is bigger than C. But so that's the smallest, second smallest, bigger than the largest. Okay. So I should imagine like A, B, and then very long C. Check that A plus B is greater than C with, this is A less than or equal to B less than or equal to C. Okay. So in these examples, there's a 3 through 3 where I have to remember that I wrote equal, less than or equals to. But that's fine because 3 plus 3 is 6 and that's bigger than 3. Welcome to Oxford. 3 plus 3 is 6. And over here we've got, these ones are not in order, so I've got to remember that A is supposed to be the smallest. Well, no, that's not quite true. A is the first one. But then if, this is like, if they're in order, then it's that. If they're not in order, you're on your own, but, work it out. It's just a triangle that's been rotated or something. This is kind of symmetric. we're going to see that any permutation is fine. Sorry, 1, 3, 2 is not okay because smallest plus the second smallest is the same. Yeah, and that one we want a strict inequality. Okay. Oof, we're still there? Still there? No, so all of your answers will be on paper this year. To answer the question in chat, you're going to tick boxes for question 1, and then there are pages for you to show your working out for the questions. The questions, you'll see them on the screen, writing on paper. Okay. Hi, Lester. Right, good. Gap year statement. You could email the college if you like. There's nothing to stop you. If you want to email the college, Grundy. Sorry, this is my multitasking. What was that about attention spans? Anyway, right, okay. What I was going to define for any positive integer p, we define that to be the number of triangular triples which have that perimeter. Okay, so we're going to do some sort of counting problem. Triples with the same numbers but in a different order count as being distinct. Ah, great. Okay, so here are some with 3, 4, 5 in different orders, which adds up to 12. But these all count. Okay. We're asked to write down the values of f of 3 and stuff. I've now read ahead to the bit of the question. Right, okay. You can sit MAT if you're applying to Oxford, Imperial or Warwick, but otherwise, no, it's not an open examination. And it's particular courses at those 3 universities. Technically, it's not open qualification, it's a part of the admissions process. I know that's weird. Space for short answer questions is very small. There is more space this year because the short questions are no longer printed, so you get extra space in a way. If you need more space, there is some space at the back of the booklet. This is explained on the front of the answer booklet as well. Okay, this is good juggling. Are the question 7 still relevant? Yeah. I take quite a broad view. I think lots of things are relevant to lots of people. If it's a maths question and you can't do it straight away, you're probably practicing. Okay, right, broad view of what this question is like, and you can tell me in chat which bit you want me to do. So values of some things to check. We've got some initial numbers, and then we've got some working here. If ABC is a triangular triple, show that adding 1 means it's also a triangular triple. Okay, I can kind of see that. If you make all the sides of the triangle larger, it's going to be fine. And X, Y, Z, even number greater than 6. Show that each of them is at least 2. So there's kind of 2 things to do here. 1, show that here, and that if this thing where you subtract 1 from each side is also a triangular triple. Okay, so I guess I hope that none of them are 1. Oh, I'm going to show that there are at least 2, so you can subtract 1 from each of them. Okay, fine. Show that you can make the triangle smaller in some cases, but not all cases. Interesting. And now I love it when questions do this, using the previous 2 parts, because we get to use some understanding of what we're doing. Part 3. If you need more space, it's really unusual for someone to need more space than there is in the booklet. That really doesn't happen very much. If you think it's going to happen to you because you have, I don't know, dyspraxia or extremely large handwriting for special needs reasons, some sort of special access requirement, then you should talk to your test centre about making some sort of access requirement request. If you get like a large booklet in other exams, then maybe we can work that out for MAT as well. But if you want to be given more paper than you're going to be given, then I hope you realise that at some point that's a kind of paradox, right? There's an amount of paper that you're going to be given, and are you going to be given more paper than you're going to be given? Kind of no by definition. Okay. And there's not me being mean. It's just at some point people will start complaining about the trees as well, right? I'm cutting down a lot of trees for this. Right. Okay. 3 is tricky. Good. Okay. 4. Using previous parts, prove that, and then this says something like, I guess 2k minus 3. So 2k makes me think even, and minus 3 makes me think you subtracted one from each of these sides. Using the previous 2 parts, so I guess this is like, for each of these there's one of those, and for each of those there's one of these. You can go both ways. Okay, and then there's quite a long part 5. show that in this case, ABC is a triangular triple because blue plus C, if and only if each of A, B, and C is strictly smaller than S. Woof. Okay, so they've got to be not too large compared to S, which is half the perimeter. Okay. And for any A such that this, show that the number of possible values of B such that this, that's got perimeter P and two of the sides are A and B, is a triangular triple. The number of possible values is A minus 1. Like, how many values can you put on B? Crikey. Okay. Hence find an expression for f of B for any even P greater than or equal to 6. Oof. Okay, so there's a lot to do down here. Find f of 21. Okay. Asha, if you have an access requirement like that you need a word processor, then please do talk to your test center so that we can work something out. We do these on an individual basis, really, because we want to do the right thing for candidates. Is there a bijective mapping between? Miles wants to use the word bijective mapping. Triangular triples for 2k minus 3, triangle triples for 2k. I think that is, well, we're trying to show that there's some correspondence between them. I think it's true. Bijective means for each of these there's one of those, and for each of those there's one of these, which I think is what we're going to do using those two paths. Okay, once we got down to this counting part, there's going to be some not terribly difficult part at the end to count the f of 21. And the way we've always run it is to ask you to write everything in the booklet, so that we get to see what you've done. What I don't want is for people to contact me afterwards and say, "Oh no, I wrote some stuff on scribbly paper when I meant to write it," and you have to believe me that on my scribbly paper I wrote f of 21. I just don't want that kind of stress after the exam. So we've always asked people to write everything in the answer booklet, even if you think it's scribbly rubbish. The markers are used to it, and there's a chance that it's not as scribbly rubbish as you think. Good. Okay. Sometimes people do scribbly rough work at the back, and I get that some people don't like submitting scribbly rough stuff, but you know. If you can show a one-to-one correspondence that goes both ways, the sets are of equal size. Let's quickly think about how that bit's going to work. So this is the kind of mechanics of the question, right? The part 5 looks to me to be extremely difficult. Talking about all these if and all these clauses and counting and if it's this, if and only if. There's like a lot going on. Part 4 looks like it's building towards some sort of idea, right? F of 2k minus 3. You do not need to know the words bijective, injective, and surjective. What we're gonna see now is some idea that for each of these there's one of those. So for example, this shows for each triangular triple perimeter 2k minus 3. So for each one with perimeter 2k minus 3, this means that there is one with perimeter 2k. Oh, with perimeter 2k. So for each one of these, there's one of those. Now that's not quite the same as saying that there's the same number of each, right? It says that you could take the small triangles and make them larger, but there might be loads more large triangles that aren't made by starting with a small triangle and expanding. For example, you can imagine maybe there could exist some really long, skinny triangle with a very small side, which doesn't come from expanding all the sides by 1. Yeah, okay. And 2 people at once have asked about rigorousness of explain your answers. We're not expecting you to win the Fields Medal on this. We're not expecting sort of professional paragraphs and descriptive stuff. We're expecting you to write enough to show that you've had the idea, or that you have some understanding. Like for this, show that down here, if and only if. looking in part to show that people are having a go at explaining both directions. So if and only if means, on the one hand, if this then that. On the other hand, only if that then this. It goes both ways. I'm going to say that once again because I think I might have got it wrong, and I always give myself a second chance, and I hope everyone else does too. If and only if between two statements means this if that, and also this only if that. This only if that is a bit like not that implies not this. Anyway, yeah, I should stop talking. Andrew's written like 3 pages of just words for the last bit. My goodness, there's got to be some expressions in there as well, right? Because you've got like A-1. I don't know. Maybe you have different descriptions of different descriptions of literature. It's both directions. Wait, hang on. So this is an interesting comment, right? Over here, there's a comment. For if and only if, do you have to go both directions, or can you say, and then they've done both directions, right? This is you doing both directions. There's the but. You did both. You got both. You're right here. And 1, and then 2. I find this yeah, you're good. Yeah, you got to do both directions. What am I saying? What do I do right now if I don't understand this question? Anonymous, you're in the right place because we're about to talk about it. And my plan is to talk about this until people are happy, or at least until people get there. Hang on, let me try and break this down. Hang on. Some of these things are the same, right? And I'm on camera, so it's impossible for me to get this right out loud first time round. But some of these concepts are the same. Because things are in this world, things are either true or false. I mean, if they're not true, they're false, and if they're not false, they're true. So you can kind of flip things around, which is confusing because your whole question there is about flipping things around in the sense of going in the opposite direction. So checking that if X is true, then Y is true is the same thing as checking that if Y is false, then X is false. Yeah. Because once you've done that, suppose X is true. Now Y can't be false, otherwise it would imply X is false. So this is not helpful, but in the notation of sort of logical stuff, if X then Y is equivalent to not X implies not Y implies. You see, I knew I'd get it wrong. X implies Y is the same as not Y implies not X. I'm so cross with myself. Yeah, so it's called the contrapositive. This isn't, again, the language is not helpful, right? And the symbols are not helpful. Maybe I'm gonna have one more go at suppose you've done some work and said, I've proved that if Y is false, then X is false. But what I really want to know about is what happens when X is true. Well, I can come in and I can say, oh, if X is true, then suppose Y were true. I can come in and I can say, if X is true, suppose Y was false. Well, then by the thing you just did, Y being false would imply that X is false. But we're thinking about X is true. So if X is true, then Y has to be true. It's sort of the same thing. Okay. Gosh, that was not helpful. If all questions are like this, good news, only this question is like this. The others are all different. Venn diagrams would have been such a good idea. Too late now for me to see that chat message. Good times. Right, okay. I think just to get us happy with this first bit, I am going to do the first bit of the question. So for F3, you could have the triple 1, 1, 1. Do these numbers have to be greater than 0? I think they probably do. Yep, they are positive integers. Positive numbers means bigger than 0. Triangles don't have 0 as one of their sides, I guess. So for F of 3, and that's all you can do. You can't make the sides longer because 1's the minimum. If you make them longer, it's not going to work out. And that is allowed as a triangle. That's a little equilateral triangle. For F of 4, I suppose you'd want this, but then it's not true that a plus b is bigger than c, because here a plus b is equal to c. So f of 4 I think is 0. There are no triangles that work with perimeter 4. For f of 5, you could imagine doing, so the triple could be something like 1, 2, 2, or it could be 1, 1, 3. But actually, this one doesn't work because the ones are too small. 1 plus 1 is not bigger than 3. 1 plus 1 is 2. Welcome to the Oxford MAT Livestream. Over here, though, 1, 2, 2 is allowed, and actually, I can then cycle it around. We saw up here that these all count, so I could cycle this around to give me some other triangular triples that correspond to just like the same triangle but rotated. Okay. Good. If there's a question that doesn't ask for an explanation, do I have to use any words at all? No, I reckon you can just find it with numbers. Right, down here, like this one, doesn't ask for any words. Just go for it. What about 2, 1, 1 for f of 4? Well, so 2, 1, 1 is interesting, right? Because the real definition up here, the first thing we see is the sum of any two of the numbers is strictly greater than the third. So in the sequence 2, 1, 1, that's not the case, because we need the sum of any two to be strictly greater than the third. The example they've given us of this kind of shortcut is that if the numbers are in order, then we can just check that a plus b equals c, which your example does, but they're not in order. Oh, sorry, just dropped a pen. They're not in order in your example. So that was probably, I'm really sorry if you're on headphones or something. Unacceptable levels of noise. For f of 6, we can only have 2, 2, 2. The other combinations sort of don't work. After that, it's starting to get a bit hard to check possibilities because there's lots of different ways to make 7 or 8 using small numbers. But, you know, could be better, could be worse. Right, okay. Just to confirm, to prove if and only if, show if A then B, and if B then A. Yeah, that's fine. Or show if A then B, and if not A then not B. Yeah, that's fine. Yeah, let me think for 10 seconds. There's more than 10 seconds. Yeah, I think you're good. I think you're good. Yeah. We can do this. We can do this. I find it so hard when it's presented in terms of like the abstract statements, right? This abstraction where you go from having like actual statements like I'm wearing a hat or I'm not wearing a hat to P's and Q's and A's and B's and X's and Y's. I find that abstraction super difficult, just so hard. Which means I've given them worst advice possible, right? Okay, so over here for part 2, let's say that if they're in order, now you're probably shouting at the screen, what if they're not in order, right? Because we just had this chat about 2, 1, 1. If they're in order, then this is kind of obviously true, that a plus 1 plus b plus 1 is greater than, because a plus b is bigger than c, ABC is a triangular triple, it's greater than c plus 2, which is greater than c plus 1. So this is fine. The sum of the two smallest ones is bigger than that one. So if in order, then still in order. And then I put in a sentence, very short sentence, to say something like, and a rotation of a triangular triple is also a triangular triple. Now, that's if you're a stickler, that's not really enough detail, right? Because I need to say, or probably something like, the rotation of the first one and the rotation of the second one is actually equal, so the thing I'm checking is fine, but I need to check really that it's like rotation and then inequality and then unrotation to get back to the right order. But if you write a short sentence like, and you can write these numbers in any order, so assume they're ordered. If you write something to say, oh yeah, I'm aware that they might not be ordered, but it doesn't matter, then morally you're kind of right. You've made the right point that if they're not ordered, it doesn't really matter. Good. Okay. Sorry for the background noise. I am right next to a building site, which is going to be a building site for the next 2 years. Lucky me. But part of the new building is a new cafe, so I'm very excited for that, which is right next to work. Work already has a cafe, but variety is good. Love a cafe. Okay, part 3, which someone in chat said was the hardest part for them. This is really bad. I've had 1 week off and I've completely forgotten how to use Miro and live streams. Now I'm wearing a hat. I've really lost track of chat as well. I'm not used to this. I've been doing this for 4 years. Right, okay, 3. So here, the trick is going to be, we want to kind of undo this. The problematic step is that over here, we kind of subtracted a 1, right? To get from the +2 down to a +1. And to be able to get away with that in the other direction is very difficult. I'm not making much sense, but we kind of have a stepping stone in the middle here. In between the things that we want to prove, we have this kind of convenient thing in the way, in between, where we sort of know 2 facts about this middle stepping stone. We know that it's less than that, we know it's bigger than that, so you can piece it back together. In the other direction, we don't know the same information. We don't know the stepping stone is there, so we can't just reverse the argument, if that makes sense. You would want to write something like given x plus y is bigger than z, saying maybe they're in order. You would want to write that x minus 1 plus y minus 1. Now I want to say that's bigger than z minus 1, but the problem is it's not. This is bigger than x plus y minus 2, which is, I suppose, equal to x plus y minus 2. So it's bigger than z minus 2, which is then not bigger than z minus 1, right? It's smaller than z minus 1. So no, you can't really chain together these inequalities in the same way. The kind of stepping stone that I wanted to be in the middle is, the corresponding version here is not in the middle, so it's very annoying. Oh, Andrea, I agree. I'm going to thumbs up this thing. You're good. I'll give you the thumbs up so that we're good. Yeah, picking red and blue balls out of a bag sounds reasonable. If you want more examples of picking red and blue objects from a set of objects from some collection, I'm being abstract, other collections of selections, then you can check the, we did an episode a couple of months ago on that section of the MAT syllabus. So I've forgotten where it is, but watch all the past episodes that were on particular topics, and you'll see some other examples, or just skim through the worksheets on the MAT Live website. MAT Live website available there for you to find more questions about selection. Right, okay, so this did not work. And perhaps more to the point, I've also ignored part of the question. I haven't done this at least 2 thing. So I should probably engage with that, right? I haven't used the fact that the perimeter is even. So fun fact, by the way, this thing we're trying to prove is just not true if the perimeter of the larger triangle is odd. So we do have to use that even number fact. This is a good skill to practice, by the way, is to, if you're having trouble proving something, this takes time, but if you're having trouble proving something, to try and prove a related thing or to disprove a related thing, that can help you find the edges or find out what matters, find out what's important. I'm trying to think of a concrete example, but if you're trying to prove that all dogs are great, then you're going to prove that all dogs are good dogs and brilliant, then that can be a little bit tricky because there's lots of dogs, but you might like to imagine, what is it about sharks that makes them less good as pets, right? And if you can prove that sharks are not good pets, then that starts to give you some boundaries to realise like good things about dogs, which you might not immediately think of. You might not immediately think of when you're just comparing different species of dog or trying to imagine all of the dogs at once. All of the dogs are good dogs. They're all good dogs. Alistair Bishop, there is no official weighting. Luckily for you, we use humans to look at the applications rather than feeding the data into an algorithm. We I don't want to feed the data into an algorithm. I would say that math score is pretty important because it's actually a maths test. It's you doing some maths for us. We also do look at your personal statement and references and vice versa as well. Okay, 56 is a very nice number. I think you've done 4 timetables. Okay. Oh. See how the 2023 one goes as well. I don't think you should worry so much as if you want to score more than 56 on the next one, then I need to practice some more maths questions, I think. Okay, up to you. Right, good, okay. What are we doing? So we had something went wrong. Something went wrong. This approach didn't work. It was close to working though. Z minus 2 is really quite close to Z minus 1. So this doesn't feel like an unrealistic idea. What have we got? So let's try and do this proof that each of them is at least 2. Now, because of the way the stream's set up, I'm writing in such a tiny space. This is kind of ridiculous that I'm trying to write on the questions. Obviously, you're not going to write on the questions. I'm actually trying to think about if I can put a kind of split screen in here. Let's give it a go. This is a bit improvisational, but I'm going to try this. Yeah, okay, and then I fill this. Maybe I shouldn't improvise stuff on the stream, right? Fill this and lock it in place. Good, and then that gives me a little bit of space underneath. There we go. Okay. Hey, why don't I do this more often? This is great. Oh, I guess I'm going to have to delete everything in a second. Oh, never mind. It's faff, isn't it? Messing around. Real fun is here. Oh, hello again. Okay, here we go. So we've given that x plus y plus z is even, and it's greater than or equal to 6. We're going to show that each of those numbers is at least 2. Okay, so I guess we're going to have to go, suppose x less than y less than or equal to z. Why not? A mathematical thing to write here might be like without loss of generality or something, but we've kind of agreed already that the order of the numbers doesn't affect whether it's a triangular triple or not. You can always spin the numbers around. I guess the definition is symmetrical. It refers to any 2 of the 3. Anyway, I'm going to write why not, and then suppose, and this is for contradiction, that x equals 1. So for contradiction here kind of just means, suppose, to see what goes wrong, what happens if x equals 1? Because we're proving not b implies not a. Anyway, never mind. Suppose x is 1. So I'm trying to prove they're all at least 2. What would happen if x equals 1? Well, then we would have 1 plus y plus z would be even. So y plus z would be odd. That would be 1 less. So I guess one of them's odd. Where am I going with this? What am I trying to do? I suppose we would need 1 plus y to be greater than, actually greater than, for the rules, this. We've got them in this order. We need this to be true. We need 1 plus y to be greater than z. So y is kind of smaller than z, but pretty close to z, right? Because y is less than or equal to z. 1 plus y, the next number, has got to be bigger than z. That's a bit weird, but these are whole numbers. There are gaps between the whole numbers, so y is equal to z. But then y plus z would be even. It can't be even and odd. So this kind of investigation concludes that the only way out, so this is the only way out, is for x to be greater than or equal to 2. Okay. So there's a proof by contradiction on the board. I'm not sure whether people know this language or not, but hopefully it makes sense that we're exploring what would happen. It's kind of hypothetical that if we're not in this situation where each of them is at least 2, what's going on? Okay. So I think, yeah, each one's got to be at least 2, because if one of them's 1, then you run into this trouble, and the trouble really relies on even and odd. Why am I thinking about even and odd? Because it says even in the question, and because I suspect that that's going to become relevant, so I'm exploring. Often in math questions, you are exploring around, and although I have done this question before, I'd forgotten how it worked in the details. So just now, when I was writing this part on the screen, genuinely, for most of it, I couldn't remember where I was going or what I was doing. The strategy that I've developed really is to write down things that I haven't written down yet that we know from the question. If I've run out, go and look at the question again. And I had to remember around here that I hadn't yet said anything about triangular triples. So I should write something down. And then once you've written it down, you get a chance to process it and move on to the next bit. If none of them will be 1, we can take 1 away from them, be it to 0. That's not allowed as a proof, because who said anything about being able to take 1 off? We don't yet know that this is a triangular triple. And you've got to be careful, because there are triangular triples that have 1 in, for example, 1, 2, 2. That is a triangular triple. If you subtract 1 from each of them, that will be 0, which is a side length, not a side length of the triangle. Sure, but that doesn't disprove that this triangle exists, right? Here it is. Here's a triangle where you can't subtract 1 from each side. So your proof has got to somehow realise that it's not automatically allowed that we can subtract 1 from each side. We're about to prove why you can do that in this case. Our proof is going to rely on the idea that the sum here is even. Can I talk more about what I'm doing? Want to do in the future? Write stuff I've already done in personal statement. Yeah, sure. It's a personal statement. You can do anything you like. You can write anything. You're encouraged to write it so that you're demonstrating how you are prepared for university. Writing about aspiration about the future might line up with that if you're talking about what you're looking forward to doing at university. If your personal statement is entirely I want to go to the moon and the moon is going to be absolutely brilliant when I get there, then obviously that's kind of aspirational, but it might not be relevant. So keeping it relevant is more important to me than the tense. Why do we need that? Because, let's put a because in, x, y, z is a triangular triple. And the definition of a triangular triple with the numbers in order is that you check that x plus y is bigger than z. If your predicted grades are lower than the required marks, is there any way for me to compensate for that? Please answer. Well, we know that predicted grades are often wrong. So if you apply, tutors will be looking out for evidence that your predicted grades are not a true indication of your ability. Lots of ways that might happen. For example, the rest of your application might be really strong, in which case tutors might think, maybe this person is on track to do better than their predicted grades. I think they're wrong in about 25% of cases, which is quite a lot. Okay. Really intriguing personal statement. Now that sounds intriguing in itself. I wonder what you think an intriguing personal statement is. It's information transfer, right? You're telling me information. If I'm intrigued, then maybe the information hasn't been transferred, and you should rewrite your personal statement perhaps to be less intriguing and more informative, or maybe intrigue. So down here, these are whole numbers, and we know on the one hand that y. Let's rearrange this one. This one says this is a big long snaky arrow. It's not supposed to be an implication or anything. I guess it is though. Y bigger than z minus 1. So we've got this situation where y is on the one hand quite large. It's bigger than the number before z. But on the other hand, it's quite small. It's most z. So this is quite a strange situation for whole numbers. This says, what do you know, z? Let's say z is 37 or something. Then this says, well, y is bigger than 36, but it's at most 37. That makes you suspicious, right? It makes it sound like the integer is 37. If it's at most 37 and definitely bigger than 36, then you're like, that doesn't leave any other cases. Key fact there, because they're whole numbers. And whole numbers have got big gaps between them, which you obviously know because you learn about counting when you're very small. But the older I get, the more I respect the importance of the large gaps between the whole numbers. how to structure it so that people know what you mean. I prefer it if people work down the page rather than in a kind of Ulam spiral outwards from the middle. It's genuinely much easier to understand you than you would maybe guess. The people marking it know what the question is, they know how to do the question, and they see lots of attempts. So they, in some sense, have this kind of supernatural ability to understand what you're trying to say due to sort of knowing what you might be trying to say. Your teacher does, so your UCAS referee does the predicted grades. Thanks, Fermat, I missed that question and then you picked it up. You're doing my job. Okay. I'm not sure I like talking about personal statements in the middle of question 5, but we'll keep going, I guess. Okay. Once we know that each of these numbers is at least 2, then we can subtract 1 from each of them. The only thing we need to check now is that, oh gosh, that x plus y minus 2. So now we just want to show, I'm going to erase some of this. No, I'm going to scroll. We also want to show that x plus y minus 2, so some of the smaller sides, is bigger than z minus 2. Now, we know that x plus y is bigger than z. That one is a triangular triple. So I hope you agree that x plus y minus 2 is greater than z minus 2. We wanted to show it's bigger than z minus 1. That's how triangular triples work. Error. Out by 1. Okay. We want to show that x plus y minus 2 is bigger than z minus 1. Irritating. We know that it's bigger than z minus 2. If you're bigger than z minus 2, then you are almost always bigger than z minus 1. So bigger than z minus 1, bigger than or equal to z minus 1, because they're whole numbers. And again, this is the property that if somebody tells you that this whole number is bigger than 35, you say bigger than 35, like strictly bigger than 35, like it's at least 36 then, isn't it? Is x plus y minus 2 equal to z minus 1? Now this would not be allowed for a triangular triple where we want some of the two smaller sides to be larger than the other side. And the answer to that is going to be no, because odd even. Now I'm being cheeky, like I might get a mark for this, but maybe I can explain this a bit better. And I think you've got some intuition, right? That I've probably got some idea about oddness and evenness, right? So maybe I deserve some mark, but I definitely haven't explained it enough, right? So maybe I shouldn't get all the marks. I don't know if that lines up with how many marks you think I should get for this, right? I've rewritten no comma because odd even. Like on the one hand, I've got an idea. On the other hand, maybe I'm just bluffing. Maybe I'm guessing. I should probably follow through and actually explain what's odd and what's even, right? If I'm bluffing, then there's a chance that I'm just bluffing completely incorrectly. Maybe this question is actually supposed to be, doesn't work if you think about odd and even. Good, okay. I wonder what chat thinks. Let's read chat very quickly. Would you be expected to solve differential equations? No. That was an easy question. Your teacher said you don't need predicted grades. Andrew, we would quite like some predicted grades. Please show your teachers the UCAS website. On the UCAS website, there's a section that talks about predicted grades as a thing. People's UCAS referees almost always put them in the, there's actually a separate box, but part of the UCAS reference. Good, okay, we're doing what we're doing. I think I asked chat a question. I'm politely waiting to see if chat wants to answer this. But chat wants to ask me, does it matter if there are no lines between paragraphs in my personal statement? I shouldn't laugh. Chat, that's fine. It's fine. Don't ask me if it counts as a character or not, but if you write your personal statement in one big paragraph, I can still, humble bracket, I can still read those words. You're going to be fine. Perhaps the interview went really badly. That's kind of a good experience, right? Because that means you're going to think about the question that they asked you, and you're going to think about that maths. You can learn from this experience, maybe. Okay. Yeah, minimum value. Can you also show that when they're not equal to, the inequalities will always hold true? Well, who said about all of them being equal to 2? Or those slashes meaning one of them is 2? You proved it for the minimum value of x minus 1 minus z. No, loads of things are true for the minimum value, but then not true in general, right? Like the statement p is prime is true for p equals 2, but not true in general. So you can't just check the smallest number, right? Also, 2 is not the smallest number, so good. Okay. Everyone's writing their personal statements. I get it. Patricia's right. There's 2 weeks. Any of x minus, we can assume it's 1. Then at least one of x minus 1, y minus 1, z minus 1 is 0. Yes. True. Correct. Therefore, this is not a triangular triple. True. Because all side lengths must be positive. Yeah, that's absolutely correct. It is not what we're trying to prove. We're trying to prove that the much harder thing, that if x plus yz is a triangular triple, with this summing to an even number, then this thing is a triangular triple. What you've told me is, yeah. So we've got to show that here, right? We've got to show that each of them is at least 2, and that is also a triangular triple. You've shown me that these things can't be simultaneously false, I think, but there's still wiggle room in there, right? You've shown me that if one of them's 1 and that thing is a triangular triple, then contradiction. But okay, now you have the challenge of showing me that the first thing is. No, you have the challenge of showing me the second thing's true, right? If you assume that this is true, then you can prove this. Now you have the challenge of actually proving this, which is what I'm doing now. So let's go and do that now. We're on question 5 still. New format. We spent 2 hours doing multi-pass paper, which apparently means I spend an hour talking about one question, and actually an hour talking about half a question. But you know, I'm having fun, so that's all right. We're on question 5, but question 5 has disappeared way up there. So let's do this odd evenness thing. So this would be if that, then x plus y would be z plus 1. X plus y plus z would be 2z plus 1, but this is even and this is odd. And now I've added in a couple more lines, I think it's clearer what I meant by the odd even thing. So I'm being a bit cheeky by withholding the truth from you in a way, but maybe you had some ideas like this in your head and you knew that I needed to write down something like this. You can do steps like this to force the contradiction. Right, proof by contradiction, good strategy. Okay, my formatting here means that I now want to delete this and this, so we can look at the rest of the question. Okay. Well, right, okay, let's read chat. Fourth bar, RNav, yeah, I like this. You increase each side by 3. One plus one is not the only way to increase it, because you could go from 10, 10, 10 to 13, 10, 10, and that's fine. Those are both triangular triples. Last line again. Oh yeah, sorry. So now I've deleted it, right? But the last line that was on the board was just, aha, I could force this thing. So I had, in this particular case, the only thing we needed to check was check that that's not equal to z minus 1. And my plan was to add z to both sides so that I would have an odd number and an even number. We still know that this thing is even. That's odd. Good. Is it enough to say that x minus 1, y minus 1, z minus 1 fulfill the necessary and sufficient conditions for being a triangular triple? Yeah, sounds good. Yeah, good, okay. So part 4 is really just linking together the previous parts. To say, in this situation, you're allowed to go not only from the small triangle to the big triangle, but also backwards from the big triangle to the small triangle. It's why I've been saying things like 10, 10, 13, which is, if you like, it's a way to take the triangle ABC, and it's a way to make a different triangle of perimeter 3 larger. So this should really worry you, right? We did triangle and triple, and we did different things to it to make a larger triangle. But in the even case, there is a 1-to-1 correspondence, where you literally increase each side by the same amount, which is maybe the most obvious thing you would try, but it's not the only thing you could do. You can increase one side by 2 and one side by 1. Sometimes, in some situations, you can do that. There are other increases that you can do. Okay, low but still a requirement for predicted grades. Okay, tick. Strong math score, double tick. Considered for interview. I think considered for interview. Yeah, we'll see. Yeah, that's fine. Didn't my condition show that release tick? Sure. So you assumed that it would be a triangular triple, and use that as your kind of reason why it's not okay to have some 2s in there, or to have some 1s in there. You should, if this is a triangular triple, if we can always rely on this being a triangular triple, then I can subtract 1 from each, and then show the other condition. Yeah, I can then show the other condition. Fine. You can show the other condition. And make sure you check that the numbers are bigger than 0, of course, because nowhere in my work did I check that x minus 1, y minus 1, z minus 1 were all bigger than 0. Obviously you need to check that too, right? To check that they're triangular triples. Otherwise, you know, they could be like minus 10, minus 13, and minus 6 or something, and that's you should check they're positive. Okay, you end up doing the work anyway, right? You can't always dodge it. Right, what do I want to do? So part 5 is actually not too bad once you get into it. These possibilities are kind of bounds on how large the sides are that really do work out in a logical way. It's hard because the actual inequalities you write down look really messy, and if I start writing them down, I'm not going to go at the right speed. I just know I'm not going to go at the right speed. So I always think it's not helpful for me to try writing down the inequalities. You can access them. The web solution has got loads of inequalities. I want to talk about the idea more than the actual like precise inequalities. I think that's where we add value by doing live things. So someone in chat's asking about logic questions. Obviously, I can't tell you whether there's logic questions in the future. Like, I just can't comment, right? Is there a possibility? Sure, there's a possibility of anything though. Don't understand part 4. Could you go over it again? Okay, let's do the big ideas. So on the one hand, we've got this big collection of triangles with perimeter 2k minus 3. That's a bit of a weird idea. I'm going to pick a number for k. I'm going to illustrate this for k equals 5 or something. So on this side we've got perimeters of triangles of perimeter 10, and on this side we've got triangles of perimeter 7. Let's think of some like 3, 3, 1. Brilliant. And you can rotate that round. And 7 is hard because there's also like 2, 4, 1. No, that doesn't work. 7's fine. Okay, there's some triangles in here. And over here, in the 10 case, there are quite a lot of triangles. There are things like 4, 4, 2. There are things like 5 something probably. I'm going to try and draw different triangles or something. There are quite a lot. Then what we showed in part 2 is that for each of these, you can do a kind of inflation thing to get to one of those. So it says that for each of these triangles, you can add 1 to each side, which is kind of a cheeky thing to do, right? There are loads of things you could imagine. You can start with this 3, 3, 1 triangle. You can imagine trying to expand the sides to like a different amount, like to get up to, I don't know, 4, 3, loads of things you could imagine doing to the triangle to try and make a triangle with a larger perimeter. But our plan is to add 1 to each side to get one of these. So this shows you that there are at least as many over here. You get different things in each case because you could imagine undoing that one case. But the other thing we've checked is that, so this is part 2 to go that direction. The other thing we've checked is that you can go the other way. That for each of these large triangles, you can subtract 1 from each side and get something over here. You don't sort of miss and end up with like a 0, 0, oops, like a 0, 0, 3 triangle or something. Oh no, terrible. That doesn't happen. You always end up in a kind of actual triangle over here, which means that there are at least as many of these as there are of those, which means it's the same number overall. Good. Okay, maybe the sets are helpful. I'm not really sure. It's like a collection of triangles that I'm imagining here. For each of these, there's one of those, and maybe some others. But no, wait, for each of those, there's one of these, and maybe some others. So it's kind of like, well, the sets can't both be bigger than each other, right? They're the same size. Space for each of those. We know that if any of those are less than 2, then x of 0 is impossible. Yeah, all of these 2. And I can prove that using even odd arguments. And you've got to prove that they're all bigger than 0. You got one more step, Anonymous, at the top there. You got one more step. You just got to prove that all those numbers in the new triangle are bigger than 0. Because they're supposed to be positive, right? And it's not obvious that they're positive afterwards. It would be impossible for a triangular triple, but in your last step, you're trying to show me that's a triangular triple, where you check the inequality, and you're going to be talking about positive numbers. Yes, okay. Good, right, 5, which I think I should stop talking about this question at some point, sorry. There are some bounds on A, B, and C that you get by thinking about this, thinking about what would happen if one of them was bigger than S. And there's not very much perimeter left over for the other 2 in that case. And then once you've bounded them all, you can start to work so that you say, well, okay, that means that A is somewhere in between, because A is bounded by S. It's not as big as S, strictly small than S, so it's somewhere in this range. We know from the previous part it's at least 2. From way up here, we know it's at least 2. The sum is even right here. So the number of possible values of B, we got some constraints on B. So maybe we know that we know the total sum. Oh, that's going to be P. That's fine. And we know some inequalities about triangular triples. So we can turn those inequalities into facts about B. It's not too bad to turn them into facts about B. By this point, we know triangular triple facts. We know a range for A, so we can kind of bound B as well. It turns out that B is in some quite narrow range. More narrow depending, or less narrow depending on A, but that just falls out of the possibilities of what B can be. If A is very small, then B needs to be quite large to compensate, to try and make up like the idea that A plus B will be quite big. You can't have A and B being quite small. So A maybe explores all of this range, but then B is a bit more limited. And then you can add those up, the different cases. Yes, there are more than one way to add 3. So you can do, if you're doing different operations, you can So I kind of said the thing about adding 3 to one of the sides, because someone in chat was talking as if adding 1 to each side was the only thing that you could do, and that's not the case, because you could add 3 to a side and sometimes get away with it. The confusing thing here is perhaps that 9, 9, 12. If you add 1 to each side, goes to 13, 10, 10. And there's this kind of separate world where I started with 10, 10, 10 and added 3 to just one side, and that also goes here. So now I'm kind of doing some overcounting if I think of those as separate, and it gets very complicated. So kind of thinking about other operations, it's healthy to remember that that's a thing. Nobody said you had to add 1 to each side of a triangle at any stage, but it's the way that we're doing this question. The reason I want to say stuff like that is that sometimes it can really feel like you're on rails and you're not sure what to explain, because the thing that you're doing feels so obvious that you can't imagine anything else. It's like the dogs and sharks, right? Again, to think about the opposite, to think about something else that could be going on, to give yourself more of an idea of where the parameters are. I don't know. There's a lot of thinking, a lot of extra stuff. Okay. No. Your proof is circular. You can't do this. This proof will be circular. You've already shown them if you assume it's a triangular triple. I let you do that eventually. But if you assume that this is a triangular triple, then you've shown that at least 2. You can't do it. You can't say assuming that one this, assuming that one this. No. Okay. It will become circular. I will only let you use the fact that x plus y z is a triangular triple. Yeah, I think I'm good. Yeah, good. Okay. Right. Okay. Bit of counting at the end. That's question 5. Right, okay, we're going to do a very short break. I'm going to drink some water. We've been live for about an hour, so remember to blink, look away from the screen. Remember everything else that isn't math questions, triangles. For context, question 5 is written by the computer science department. It's one of the ones written by the computer science department. So, you know, can't blame me. I didn't write this question about triangles. I do quite like the idea about the triangles in the middle, but there's a lot of work down here, and I think the average score on this question was a bit lower than it could have been. I think this question was hard, which I'm saying not to throw shade at CS. If CS are watching, it's a solid question. But to give reassurance to people at home that lots of people find this question very hard. Okay, I want to do some kind of refresher question 1 stuff, just to try and lighten things up a bit, so I'm not constantly doing the same question about triangles. I think I'm going to go CD, G, H, J, if that's all right. The plan was maybe to do more questions with 2 hours. It really feels like I might be doing fewer, but we'll see. Okay, so we've got tangents to y equals e to the x. So we'll need to know what the gradient of e to the x is at p comma e to the p. But that's not too bad. The gradient there, dy by dx, is just e to the x. So this graph has got equation, and I'm going to try and write down the equation in one. So we're at the point p, the value is e to the p. So I need to write down gradient is also e to the p. So gradient goes here for me, e to the p, x minus p plus, deep breath, because I want to make sure that when I put in p as the value, I don't get 0, I want to get e to the p. So I should put in another e to the p over here. Okay. There's a step taker in chat. Step taker in chat. Yeah, cool. I think this might be helpful. I don't really know. My background is, when I was your age, I was doing steps, so my advice comes from a background of someone who did a lot of step questions. To use that as you will. Okay, we've got one of these lines. Where does this cross the x-axis? So I want the when y is 0. So when y equals 0, I've got e to the p, x minus p plus e to the p is supposed to be equal to 0. I can probably divide that by e to the p, right? Because that's a positive number, to get this thing, that x is p minus 1. Now, trick for the other one. Similarly for the other point, tangent crosses the x-axis. So here it was p minus 1. The only difference here is that the p has turned into a q. That's the only difference. So it's going to be at q minus 1. All right? Okay, so this is the value of, I think it's called a. Yeah, I guess we have a as p minus 1, and we have b as q minus 1, which means that we've got the rather lovely fact that p minus a and q minus b are equal. They're both equal to the number 1. Good. Okay. This is a fact about exponentials that's snuck in as a question. Good. Is the calendar question from a few years ago real life, or is it just fantasy? D is something to do with logarithms. The trick here is to work out where the intersection point is. So draw a graph, draw a sketch. We've got e to the x. We've got 1 minus e to the x, which I think goes through this point as well. And probably looks like this. So up to 1 over here, because when x is very negative, this will be close to 1. And then quickly going like that. Okay, so 1 and then going down very fast because this goes down like this. Oh, I wonder where that is. I think I don't need to know. But I think it might be... no, I really don't need to know, do I? Right, anyway. What am I doing? I'm doing some absolute nonsense. This second one doesn't go through that point at all, does it? I've done this completely wrong. It's down here. Absolute nonsense. Is chat going to call me out? Okay, good. 1 minus e to the x would start at 1. If my graph was a bit better, I would have spotted that faster, right? Start at the value of 1, then be less than 1, and crucially, we go through the origin, which I should have noticed when I was trying to find the... should have noticed when I was trying to find the x-intercept that it was 0. Okay, chat, yeah, here we go. This is a sense of the chat delay as well. Here we go, yeah. I'm just getting chat engagement, there we go. Sorry, thanks everyone. Yeah, second graph goes through the origin. I would have noticed, because I wouldn't have had any region bounded. It's on the left. So really I think I want to know that point. Where are they equal? They are equal if e to the x is equal to, add it, divide by 2, 1/2, which is x's natural log of 1/2, which is the same thing as natural log of minus natural log of 2. Okay, over here. So what do we want? There's some nice symmetry stuff going on, right? Or we could do like the difference between these two curves and integrate it. Or we could do just one of the curves and sort of do some sort of like doubling thing in there somewhere. Loads of options involving log 2 and log 1/2. I reckon you know how to find the area between two curves like this. If not, you could do something like find the area underneath the top curve and finding the area, this dotty region, area underneath the bottom curve, and do some subtraction, right? To build it as the area under the top graph minus the area under the bottom graph. Or you can do some sort of like symmetry thing where you talk about like, oh, line of symmetry in the middle, or you can even just difference of two curves, go for it. Good, okay. I can't remember what the answer is, so I'm going to cheat and looking at it. It's not very exciting at all. It does require you to do things like this, where we talked about e to the x a moment ago. And the web solution does use the line of symmetry, which is maybe not very helpful. Maybe I would like to see something like this thing minus the integral from... maybe this would be a more normal way to do the question, like this. Do the difference in those two areas. Because one of those is not super hard to integrate, right? Because there's a 1 in here, which is just fine to integrate. I think e to the x just doubles it up. No, I think I'm wrong. Never mind. Good. Does the question still work if you keep the log 1/2 as log 1/2? Yeah, nothing goes wrong. Those things are equal. It's all fine. I brought up the minus sign because I wanted to highlight that this is negative, but you know this is also negative. Just looks nicer maybe. To go directly without the area of first one minus the area of second one. No, I can't think of anything more direct than that. We do quite a bit of area take away a different area, right? Like I'm imagining something like as I've seen a past question with like a quadratic and a tangent. So you need to integrate the quadratic to find this area. You need to integrate the quadratic and subtract some triangle. And I've also seen things like a bit of a circle where you want this bit of the circle. So you need to do area of the region of the circle minus the area of the triangle. I think this kind of subtraction of areas quite a few times in different places. You've seen it too now in 3 different places. So something to try at home. Okay, we're speed running, it would seem. We're going as fast as possible. This question got me some interesting mail afterwards. People have various opinions on this. The idea here is that there's a way to pair up the terms using some sine squared, cos squared stuff, right? Which you might be thinking of as soon as you see sine squared. You might be thinking, oh, if I can find a cos squared. So what I would really like is cos squared of 1 degree. That would be the dream. If I can find a cos squared of 1 degree, because I know those things add up to 1. But there's no cos squares in the question. Rubbish. So you think, what's cos 1? And cos 1 is quite a large number. It's actually the same thing as cos 89. And there's a squared. So these things are equal. That's not. It's the same as sine squared. Don't tell me in chat. Don't tell me. Sine squared of 89. Which is over here. So these things match up. They match up like this. Sine squared 1 and sine squared 89 go together. Sine squared 2 and sine squared 88 go together. And so on. There's a term in the middle, sine squared 45 degrees, which doesn't pair up with anything. And there's this term over here as well, which doesn't pair up with anything. So the hate mail, not hate mail, but the feedback I got was that I stole this question. it turns out that other people have. This question is just too nice. Other people have asked it for other things. In my defense, I genuinely thought of this. My reasoning for this question is I thought that I was getting you to do, not the trapezium rule, but I thought I was getting you to integrate sine squared. So sine squared looks like this. The sine squared. And between 0 and 90, it's like 9 sine 90 is 1. So between 0 and 90, it's this bit. If we can integrate that bit, then we know how large the value is. If you want to integrate it with the trapezium rule, then you have to do this kind of adding, where you add together the values. And obviously, I don't want to set the trapezium rule because it's not in the syllabus anymore. But hey, this kind of simplification of the thing that comes out of the trapezium rule is really nice. Unfortunately, other people have done this question before in other places, so I don't know if they were also thinking about integrating sine squared, but anyway, it's not a good look if you think you've invented a question and not noticed that other people have used it as well. Yeah, you really want to tell me that there's a mistake? Yeah, sorry chat, I'm now switching off my own engagement stats, right? H got some votes in chat as well. I think this one is about doing some kind of sine squared cos squared. I mean, it's not equal to sine squared, but if you've seen the MAT flashcards, you know that when you see a cos squared, you'll maybe think of sine squared, and then maybe thinking of like some sort of quadratic. How do you spell quadratic? There we go. Those are my clues for this question. I guess my other clue should be something like complete the square. I think from memory, I think this 2 in the subscript is like a total red herring. Like it doesn't really do anything. Red herring, not a clue. We don't have the magnitude of the values on these graphs, so we don't know how large. Anyway, logarithms are pretty similar to each other. Okay. Turns out that I believe. Well, let's try and do the arithmetic. Right, that'd be better, wouldn't it? Cos squared is 1 minus sine squared. So this is 3 minus 8 sine x plus 6 sine squared, which I think we can complete the square on this. Chat? Do you think we can complete the square on this? I've seen the 6 now and I've got worries. I don't like it. 6? What's that doing there? That's horrible, isn't it? I suppose I can deal with it. I'm not sure I want to. Alright, let's have a go. 6 sine x minus something squared plus something else. And I'm flexible on what these things are. So this is how I complete the square. I want to get 6 sine squared, and I know that if I do it a bit like this, then completing the square is an actual thing you can do. 6 sine squared, but I'll also want to put in here something like 2/3, where I've tried to divide 8 over 6, but then divide by 2 again. 8 over 6 is 4 over 3, divide by 2 again, because of the factor of 2 from squaring. Oh my goodness. Minus 2/3. Double check. If I square it when I multiply out, I'll get minus 4/3 times the 6 is minus 8. Where's the 3 come from? I subtracted the 6 off here. So I had 9, and then this bit, it was minus 6 now. What else have I got as my final term? Oh my gosh, I got something over here, haven't I? 4 over 9, so 3, not quite 3, because I don't want this 4 over 9, 6, 24 over 9 or something. I'll simplify that number. Ooh. I'll just make a sort of screaming noise from an office nearby. I hope it's a maths issue. Oh hey, happy birthday, Andra. 4 hours of maths. I only turn 18 once. And then there's a question about whether this number's positive or negative, right? I am too sleepy to tell you. No, it's less than 27 over 9, so this is going to be some positive number, right? Like maybe even 1/3. I'm so bad at this right now. 8/3? Yeah, 1/3 on the end. Are we good? Oh yeah, okay. You plug this in place. Set the whole thing equal to 1. So the y was 0. No, that sounds great. That sounds much cleverer than anything I've done in the last month or 2. Yeah, wow. Set the whole thing to 1 and see if you can make that work. You're doing the thing where you try and find out if it's got these values where it hits 0. Great idea, because these have all got kind of different patterns of zeros, right? 3, 2 on the left, 2 on the right, 3, or like, I don't know, 4 or something mad. Yeah, they've got different patterns of zeros. Try and find the zeros. I like that a lot. I'm going to do it your way. So when is this equal to 1? It's when this is true. It's when this is true. This is the worst scribbling I've done in a while. It's when like 3 sine squared minus 4 sine plus 1 is 0, and you can factorize that. Oh, that's so good. We should all do the question your way. So sine is either 1. Oh, this is lovely. Sine is either 1 or 1/3. And then you know where sine is 1/3, and you know where sine is 1. That's so good. So you get this sine, this is the sine 1, sine is 1, and these ones are the sine equals 1/3. Right? So it's A. It's HA. Oh, that's legendary. I like that a lot. Who said that? There you go. You get highlighted for a second. There we go. You get your comment coloured in pink just for a moment. Everyone say happy birthday to Andrew. And also, yeah, whoa, yeah. Check where it's 0. Right, good. Okay. A solid bid, by the way, for taking my job. I do some sort of random complete the square thing. Chat comes in like set it equal to 0. Excellent stuff. Right, good. Is that the person who got 56 on a map paper? Same anonymous person. Hey. You get 4 marks here. There we go. I thought you were unnecessarily worried earlier. Good. Okay. J. This has no right being a square, but it is a square. So something you can do is write down some side lengths and then start insisting that they're equal to each other. It is super messy. I don't have much more to help you with, I think. If you try and do them kind of one at a time, that's sort of helpful. You could be a bit strategic. Obviously, there are 4 sides, so there are like 4 choose 2 equalities you could write down. Because you could pick any 2 random sides, work out the distances, set them equal to each other, and then that gives you like 6 different things. Except they're not actually 6 different things, because some of them turn out to be the same. Some of them turn out to be the same. So then you need to be able to spot that. Otherwise you're going to end up with a kind of 0 equals 0 situation. If you take 2 copies of the same equation and you try working with them, like doing the difference, that's how you end up with the 0 equals 0 problem. If you're kind of including the same information too many times. So if that's happened to you, that's kind of why that's happening. The thing that working systematically through the kind of combinations, you probably want to do some squaring. You probably want to do some difference of 2 squares stuff along the way. You find out that actually a couple of these apply at the same time, and from there you can do this kind of factorization. All of these are difference of 2 squares, right? So this thing just says that this condition is just the difference of 2 squares. So a different way to write this condition is a minus b plus c minus d, a minus b minus c plus d equals 0. So it's kind of saying either this or that. Well, we've got a product that's 0. We factorized it. So these conditions up here are all saying one of these brackets is 0 or the other. And as you go down in your equations, you find several statements like this, enough that there's one culprit in common, which is this term. There it is, look, a minus b plus c minus d, which makes all of them 0. And actually, this is if and only if, because the other cases can't be simultaneously true. But the kind of pattern of this question is to write down some equations. There are some repeats in there, which makes it hard, which is why it's question J, hard. There are some repeats in there, but if you eliminate using ones that are not repeats, then you can simplify things down. By the way, these kind of objects of like a minus b squared, those are just things that you get from doing like Pythagoras, right? Is that clear? I hope that's clear. When you start writing down your distances, you kind of naturally get things like a minus b squared. So hopefully if you write down distances, you get stuff that starts to resemble this. You've got like some simplification you can do on these terms. Let me do an example. So like writing down AB equals BC, those lengths, when you write that down, we'll do like this. I'm being a little bit sloppy. That's AB, and then the other one, BC, I picked out. So this equation is super horrible as these two distances are equal, but actually it's not too bad. It's a kind of softy. If you start working with this, you can square both sides, and then they both include this kind of b minus c squared. So this one simplifies down to be this equation over here. I hope you can see that, but they both include lots of things in common. So there's kind of some other stuff going on. I've only looked at one pair of sides, right? So if you just wrote down AB equals BC, then you get kind of this condition. And I believe if you work your way around, there are some other ones as well. And they're all simultaneously true, if and only if this thing. Good, okay. Should we prove first, then backwards, or prove? Oh, it doesn't matter. You can prove the two things in either order. If means the second of your symbols, and only if means the first of your symbols. Doesn't matter what order you lay the bits of maths out. Earlier I was quite critical of someone in chat who was trying to sort of do them at the same time or assume both sides at once, which is like doing both at the same time, which is not okay. Right, okay, that was a blitz through some short questions. So I skip some? I must have skipped some. Oh yeah, no one wants to see the sequence. Sequence has got a name. What are these called? Is this Sylvester sequence numbers? Yeah, it's a Sylvester sequence. If you would like to see more about this, this is called Sylvester's sequence. It turns up in, I can't remember where it turned up. It's used in Egyptian fractions, I think. Good. Okay. And it has quite a nice relationship. It's this one. You shouldn't just pick the nicest looking one, but it does turn out that that's been there's some nice relationship between like the previous ones were also the products. So you can, if each one is related to the product of previous terms, one more than the product of previous terms, then that's kind of a fact about an minus one is the product of yada yada yada, more stuff here, which is why there's a kind of plus one at the end. It's kind of this product of all the previous terms. And we had something like this on the warm-up sheet at one point, or something which involved adding all the previous terms. This thing says multiply all the previous terms. A kind of similar idea. Okay. The eighth term in the sequence. Sorry, let's get that on chat. The eighth term in the sequence is the cool and collected 1 1 3 4 2 3 7 1 3 0 5 5 4 2 1 8 4 4 3 6 1 0 0 4 4 3. You know, it does get quite large quite fast when you're doing this sort of thing. Is that true? I hope that's true. I hope I haven't just read out some random number. What a great trap that would be. Yeah, no, that's off Wikipedia. Good. Cool. Okay, I guess we've skipped some other short questions. Do I care about the other short questions? Oh, tangents to cubics. This question is a joke about vectors. I'm not sure it's a very funny joke, but the notation we sometimes use for vectors is like this, right? Or like x, y in a stack. And the notation we use for, oh, here they are. Here are some vectors. And then the thing we use for probability and making choices is you might use for choose two, like this, for the number of ways to choose two things from four things. Here you want to choose, oh gosh, I don't know, some number of the 3 2s and some number of the 1 1s. So it's kind of a joke about that being the same notation. I didn't say it was a good joke. Anyway, somebody earlier asked about binomial choices and picking red and blue balls. Here we're picking red and blue vectors. They're not printed in red and blue, but you can abstraction. You can label things red and blue if you like, and then we're just picking red and blue objects. To make the vector 10, 8, we need. It turns out precisely. Oh gosh, we need precisely 2 of the blue ones and 4 of the red ones. 4 reds. Blue, red, 4, 7, 10. Yes, good. So combining them together like that seems pretty sensible. So you kind of want to write. It's not a good joke. It's not a good joke. Right, let's just leave it. Okay. And there's some integration that we skipped, which we can do at some point, and dodecan, which is fine. Okay. Let's look at some long questions. We've got 25 minutes on the stream. There were some votes earlier for question 2. I'm actually going to reopen the voting. I don't know if that's controversial. We'll find out. Partly I want to look at the voting a bit. There we go. There is some votes on screen right now. So if you look, question 2 has actually got loads of your support earlier. So I want to talk about bits of question 2. Again, in chat, let me know if there are particular parts of question 2 you want to see to make sure I do them. If you're voting for question 5 now because you want me to go back to triangle hell, then I see you. Oh no, people are like changing their votes. This is cool. That's cool. I think the numbers are going like up and down. You can vote for multiple questions. You think I did a bad job of triangles and should be banished back to triangles? Question all about inequalities. I think, by the way, it's inequalities that make the question hard. In the combination of inequalities and whole numbers is surprisingly subtle. This is one of the reasons that big gaps between integers is nice. It's a good property that the integers have. If you want to get better at that interaction, you might never have seen a question which has got inequalities and whole numbers together before. Inequalities and whole numbers don't interact in the same way that real numbers and inequalities work. So you do see like pretty bizarre stuff like x bigger than 1 implies x bigger than or equal to 2, which is like not true for real numbers if we're talking about real numbers. Not even true if we're talking about fractions, but it is true if we're talking about whole numbers. So you might like to try writing down some of these nonsense statements or things that are not true for the real numbers but are true for whole numbers. So if you can make some more up, like these kind of implications that you're allowed to draw. As is often the case in this branch of mathematics, the information that something's a whole number is sometimes quite a lot of information. Counter example, while you're voting, counter example, or another example, there are loads of solutions to this equation if x, y, and z are real numbers. If they're real numbers, then there are loads of solutions, and not in a very interesting way. You just set z to be the nth root. You let your friends choose x and y, and then you set z to be the nth root of the sums, right? The hard question is, are there any solutions with integers? That's a hard question, right? And where the change from reals to integers makes a big difference. Right, okay. Just casually dropping Fermat's last theorem. Real Fermat doesn't vote. 6 has got a vote. I like it when people put 6 in there. Okay. We'll see. We got 20 minutes. Let's see what we can do. If we get Wiles on the stream, yeah, okay. I wouldn't say no. My impression of Andrew Wiles is that he is not the sort of person who would be comfortable doing a live stream. If he's watching in chat, let me know. That's just inviting. I shouldn't do that. Hey, there's Fermat. Oh, brilliant. No, I prefer that form of it where Fermat turns up. It's like, hey, it's my theorem. Right, what are we doing? Logarithms. And we're going to do an overview again. I think we're now good enough at like manipulation. Part 4 is the hard part. The structure of this question is a kind of teaching section followed by the thing I've got in my head is like when you're teaching someone to ride a bike and you start with stabilizers to stop the bike wobbling, you have these extra little wheels, but then later on when they get better, you take away the little wheels from the sides. So they could fall over, but they don't. They just go. So the first part here, we've got these kind of I don't know, guide rails or little stabilizer wheels or something, which tell you to choose a particular value of x, and then use part I and this factor. There's all this like advice about how to do the question. so that you find an integer which bounds around log 2. And you see the structure here, we start with this fact we're given, we get some statement about log 2, and then that turns into inequalities about log 2, using this kind of bounding idea in the middle. For log 3, we've got a fact. By the time we get down here, we've got a fact about log 3. So that gives us this kind of fact about log 3. Now, the challenge when we're doing this part up here with log 2 is that this is not an arithmetic progression, it's not a geometric progression, but what we're doing is we're bounding it by a geometric progression. This is quite a grown-up idea, I suppose, that you could take the terms of this sequence and bound them to say, aha, this thing is small, really. It's smaller than some sort of sum. So we could do like the same idea, and if that's your intuition, that's a really good intuition, that we could do the same sort of thing over here, right? That this is 2 to the 4, this last one is less than 3 times 2 to the 6, and then do a geometric series. And that works. It doesn't give you the answer on the page. It's one more idea needed, but it does give you some true mathematics. I think this proves that it's less than 12 over 10. I might be wrong. I'll just quickly work out the geometric series, I guess, rather than trying to think. Thinking is often hard. Talking while thinking is even worse. 1 plus 4/9, I think. I want something quite a bit closer to 1. That doesn't feel right. So if I bound it like this, oh, there's an extra factor of 4 out here. 1 plus 1/9. Yeah, okay, 1 plus 1/9 rather than 1 plus 1/10. Okay, so close but not quite there. If you replace the terms with these, you get 10 over 9 instead of 11 over 10, which is annoying because 10 over 9 is actually a little bit more than 11 over 10, so this bound is slightly better. It's annoying, isn't it? So yeah. So this is annoying in a way. We had this idea about bounding it and doing a geometric series, which is great up here, and then let's down over here. It didn't work out. The way we fix it is to adapt the idea. Now this is actually a really advanced technique, in a way, to take a technique you've seen already and not do literally the same thing, but to do an adaptive version. You kind of already had to adapt a little bit because up here the powers go 2 squared, 2 cubed, 2 to the 4, 2 to the 5. Down here they go 2 squared, 2 to the 4, 2 to the 6. That's still a geometric series once you've done this kind of bounding, but turns out it's not quite the numbers we're looking for. So we've got to do something slightly better. So we're looking for a kind of a better approximation. Now, advice for the mat. Advice for the mat. I don't know why I've buried it an hour and 3/4 in, but advice for the mat. It's unlikely that you need to do something very advanced or very new. In that triangles question, we were reusing the idea that the numbers were bigger than or equal to 2. Over here, the genuine way forward is that we are reusing this idea about bounding and doing geometric series. In real life and in like actual maths problems, if you go and do research, then no one is going to tell you, oh, I'm guarantee that it's another just small tweak. But we are actually close to the thing that we're trying to do. We need to make it better. And the key observation is that when we're doing this approximation, we're kind of losing something along the way. Our approximation is kind of rough. Like that one's fine, but then these ones are not so good. So it'd be good if we could make these a bit better. But I still want the idea of a geometric series. I still want the idea that I use the same number along the way, like 3, 3, 3, so that doesn't change to make this geometric series. If I do that, maybe my idea is that I replace this one with a 5 instead. So I'm still writing down a true fact, but maybe now I'll do 5s forever. And that'll give me a different geometric series with the same kind of idea that you're bounding the terms. I guess if you like, it's the same thing, but with the rules start at the third term. That might be how you thought of it, that you go 1, 2, 3, now I'll do some bounding. Whereas here we go 1, 2, 3, now I'll do some bounding. So maybe it looks really similar to you, but it looks a little bit different to me. Like for me, it's 2 steps removed, which is maybe the most number of steps removed I can do. Okay. If you add that up now, it gives you 11 over 10, and everything's okay. 13 over 12 is sort of totally separate, and it's just related to the first 2 terms, I think, making 13 over 12. So, yeah, not too bad. Okay. Someone in chat says, anonymous person, I really like questions which teach the student an idea. Me too. I like it if you leave the mat having seen something new, which maybe you get to see again at university, maybe at Oxford, maybe not. If you go on and do maths at university, you will do at some point, I think, probably, some idea about having a big scary sequence that you bound by comparing the terms to a geometric series. Nice friendly smiley face there. This idea of comparing an unfamiliar thing to a familiar thing is sometimes like a practical use for inequalities, right? So the inequalities let you have a little bit of flex to compare a hard problem to an easy problem. So it's not an equality, these things aren't equal, but they give you a bit of flex so that you can compare different things. Okay, it's a really good idea, it turns out, which is why it's been made into this math question. I also like it if you've learned something along the way. I like interview questions that do that as well. I was talking to a student who said that, coming into first year, a new student who said that he really enjoyed one of his interviews in particular, because in that particular interview, they'd explained some new maths to him. And in that interview, he learned some new maths and he did something with it, but left just really sort of jazzed that he learned some maths. And now he's starting 3 years of that feeling of 3 years of, you're going to learn some maths sort of constantly. So this is exciting, right? For the interview to give you a little bit of learning. And if Matt can do that, then that's fun as well. What do we learn here? We do not learn very much here. There was a request for question 6, so I think I'm going to go look at 6, which means we're skipping the cake question. The cake has the return of Charlie. Charlie is here. I say this every year. Charlie is here because in the original MAT 2020, in the MAT 2020 live stream, how do you spell 2020? In the MAT 2020 live stream, people complained they were sad that Charlie wasn't in one of the logic questions. So Charlie is therefore in this logic question. There's Charlie. People want the last part 6, but the last part 6 is really hard. Okay, and it's also really hard to skip down to it. Can I remember how to do the last part of 6? Can I work it out? Let's go live. So this is about sorting a table, which I guess you might want to do for computer science, sorting things. If you just read it, it sounds obvious. It's so not obvious, which is the challenge, that things can look really obvious while actually being quite hard to explain. So quite a lot of people wrote something for this part, I think, that made it seem like it was really obvious, which didn't work. So here's the steps. What you're going to do is first sort each row. So your first operation is to sort the rows, and then the next operation is to sort the columns. So if I sort the rows, I get 24, 33, 46, 92. And if I sort this row, I get 8, 25, 26, 37. If I sort this row, I get 40, no, 22, 22, 40, 49, 81. And now sort the columns. So now I look at the columns and I go 8, 22, 24. I go 25, 33, 40. And I go 26, 46, 49. I can't read my own handwriting. And then I go 37, 81, 92. The table's now sorted, which means, to read the top of the question, a sorted table is one where the numbers are in increasing order in each row, and in each column also they're in increasing order. Now, obviously the columns are sorted because we just sorted them. Are the rows still sorted? Excuse me. That's the challenge for the question, to show that, well, in this case, look, 8 is less than 25. But that's kind of a bit weird in a way, that I've ended up with 8, 25, 26, 37. Those are in order for this row. It's a bit hard to explain why that's happened. It gets weirder actually. So 22, 33, 46, 81 is in order. And those things aren't even next to each other in the table, right? 22, 33, 46, 81. Those things are sort of spread across the table. So at the intermediate stage, those things which turn out to be sorted are just sort of all over the place. So the challenge is to work out why those things are sorted afterwards. Okay, there's a request for more 6. Specialised on it was always applicable. Argue that it's always applicable. That's the hard bit though. That is the hard bit. To argue that it's always applicable. Oh, chat, slight lag, there we go. Since you can't have repeats, this algorithm sorts it is an example of something which is, I think, sorry, but kind of magical thinking that it's kind of true that the table can't have repeats, but I don't think that's got to any of the idea about why the numbers in the row are sorted. I guess the thing is to think that there are other plausible things that don't work. I shouldn't waste any time now thinking about them, maybe, but they're kind of plausible sounding things which don't work. Instead. So the challenge is to prove that these numbers, I'm circling a lot of stuff, but these numbers are in order. My strategy is to say, well, these numbers were somewhere in the previous table. This example's awful because those numbers were next to each other in a previous table. Oh, that's terrible. Is there an example where they weren't? No. Everything's too sorted. Hang on, let me fix this. 46 and 81. So 46 and 81 weren't next to each other before. 46 is up there. At this stage, I guess I know that the rows are sorted. So I know that 46 is bigger than something. And I know that 46 is smaller than something, and I know that 81 is bigger than something else. So, oh gosh. Oh no. There's a way to do this where you consider, and the general case is much harder because the table's much larger, right? You consider something like all of the things, 46 and all of the things that are definitely larger than 46. No, yeah. Okay. So you got this kind of pairing between you got this kind of pairing. I'm going to try and draw it. Let's just draw it, chat. This is going to be fine. This is an art skills thing. You've got these kind of pairings where at this stage we know that 46 is less than 92, 26 is less than 37, 49 is less than 81. And then those pairings all get kind of shuffled because we're going to sort the columns, and the columns could really kind of be anything because the rows could all be just totally different numbers. There's currently no relationship between the things in the columns. Once we've done that, the strings kind of get a bit permuted or shuffled. And the challenge is to convince yourself that 81, in this example, 81 links to something up here that's bigger than 46. Which is nice. It shows you that 81 is bigger than follow the pink string, is bigger than 49. And now the column's been sorted, 49 is bigger than 46. So one way to do this question is to argue that either 81 or something above 81 is connected by a pink string to either 46 or something below 46. And that makes sense because there are two things here, 81 and 37. And they can't both connect to the just one thing over here, the 26. In general, there are like n things over here, and they can't all connect to the n minus one things over here. So there must be something from this column over here. I'm trying to imagine there are more small stuff above. There must be something from this section over here that connects to either 46 or something even bigger than 46. So then you've got a chain. Then you can argue, oh, 81 is bigger than that thing, the one that followed the big string, oh no, it's bigger, which is bigger than that by the previous stage, which is then bigger than 46. So it's kind of the argument that these things have been shuffled around, but by the kind of counting nature of this, there exists something over here that is larger than something over here. Something over here versus something over here. Let's do different colour for that last punchline. I'm actually quite enjoying drawing the pictures. Something over here that's bigger than something over here. Because you can't have everything on the right pointing to above on here. The pink strings are 1 to 1. Am I making any sense? Applications in, hooray! Iteratively from the top row, oh my goodness. Actually, so cool, I'm glad I'm not applying. Oh, yeah, okay, so this question was hard to mark because people's explanations were often quite complicated. Sorted the rows, the columns are gathered together. Oh gosh, okay, when we sorted the rows, the columns are gathered together in a way where the first column has the smallest group of numbers. True. And so on. What's a group of numbers? Smallest group, I mean, that collection and so on. When we sort the columns, they're already small. No, sorry. For example, 49 is bigger than 37, right? So this group of numbers, it's not true to say that they're all smaller than this group of numbers, because 37 is smaller than 49. And we're really lucky, right? Here's the thing to imagine. We're really lucky that when we sorted this column, we didn't end up with 37 at the bottom and also 49 at the bottom. Which was, we're sorting these columns separately. This could have happened, right? That we'd end up with 37 being the biggest thing and 49 being the biggest thing. It doesn't happen, but 37 ends up here and 49 ends up all the way down there. But if they're next to each other, they'd say, oh no, now the rows aren't sorted. There could be some overlap between the numbers in the columns. Gosh. Yeah, okay, so lots of questions like, do you get error carried forwards? Yeah, I suppose so. So if you mess up table B, then you might still get a mark for correctly sorting table C, maybe. Sort of depends. If you make a lot of mistakes doing these tables, then you're probably going to lose both marks. If you make some mistake, then maybe you lose 1 mark. And maybe you could see that as kind of an error carried forwards, that you made like 1 mistake and then didn't get punished for it twice. But in general, if you're at partial stuff, should get partial marks. Do we carry it through to your next part? So if you sort it and in your example it's not sorted, so you say no, it's not true. We don't carry it forwards to no, my example demonstrates this thing is false. Then no, you don't get to carry through into some sort of alternate reality. Good. Okay. Andra says, and we're almost at 7 o'clock. Don't often talk about the computer science questions, do I? What's 7? 7 was all min-max flippy majority. Yeah, majority gates. This question looks much harder than it is. Key observation for this part: there are exactly 16 of these. Can you find out why? If you can, then you've got a good intuition about, well, you've got good knowledge at that stage about what these functions are. What does it mean to be a function of 2 input variables? If you can crack that, then you've realized there's not actually that many, right? 16 is not that big. So you can make these kind of sweeping statements about all 16 of them, because any 16 is almost like none. Andrew says, I thought the problem would occur in a situation like in C, where 37 to the right of 46 is being incorrect. Well, couldn't occur, because to the right of 46 in B, we would have something bigger than 46. True. Yes, true. Which is obviously bigger than 37. Not necessarily, right? Who says that this is an, oh no, because 46 is bigger than 37. No, got it. Okay. So that would get pushed down. Push 37 down a row. So obviously it couldn't end up in its first. That sounds a lot like my counting argument, actually. That sounds a lot like my counting argument. You're saying count 46 and all the things bigger than 46. There are then some things that are larger. So follow the pink strings the other way. Those things all end up below 37, which push 37 out of the way. I reckon you can make that work. phrase it as a kind of counting argument, and in the context of the question, there's like an m and an n or something, so you can count these things in terms of m and n. Write down some stuff, see where you go with it. Sounds good. Happy birthday. Okay. Wait, after we sort the rows, there is at least one thing bigger than each thing in the previous column, since it was sorted. Good start, I like that. So when we sort the columns, even though all the small ones gravitate upwards, there'll still never be something smaller. Since if it was the pair, it was sorted above it. I'm confused about what you're saying is smaller in that step there. So I'm such a pedantic person on this, right? Are you saying the small number is smaller or the big number is smaller than the other big number? You've only got like 4 numbers involved, right? So I've got confused about smaller. After we sort the rows, there at least one thing bigger than each thing in the previous column since it was sorted. Again, it's so hard using words, right? It would be lovely if we just gave things names, like numbers, like symbols. XN or something. When we sort the columns, even though all the small ones gravitate upwards, there'll still never be something smaller. There'll never be something smaller. Never be something smaller. You mean there'll never be something smaller to the right of it? Since if it was, the pair was sorted above it. Well, the pair's not sorted as a pair, right? The pair is sorted independently. So I'm not confused. 2017 paper mentioned completing the cube. Does it? Completing the cube? I've never heard that phrase. I'm going to try and find that. I'm going to go past 7 just to find the phrase completing the cube, because I feel like I'm learning something. I've been told that in the 2017 solutions doc, there's the phrase completing the cube. Let's see if I can find this completing the cube thing. Difference of 2 cubes is in there. That's not how I would do the question. I did the 2017 paper a couple of weeks ago on the show. I did not do the difference of 2 cubes. Yes, I did not do this at all. So the difference of 2 cubes, in case anyone cares, the educational moment, which I'm not certain you have to see this. But if you like difference of 2 squares, then get ready for the sequel. Are you ready? Here it comes. The difference of 2 cubes says that this thing has also got a factor of a minus b. And then the other thing you find by like polynomial division, kind of the factor theorem. If a is equal to b, then this thing is 0. So you should expect an a minus b kind of factor. I know that's not really the factor theorem, but you know, whatever. Trust me, it works. I'm so bad at this. There we go. Polynomial division. Homework. It's not really homework, you don't have to do it. But a minus b. You should definitely check an a minus b, right? Cool. Okay. Anything else I can help with before I go and get a train? And so, Shao, if you're watching this, you're done. You're good. If you get an answer wrong in the first part and use that answer to the next part, you might get some marks for B. It kind of depends how wrong you were. Sorry, I know that sounds really flippant, but if your mistake is so large that it derails entirely, you're just doing something totally different that's maybe much easier, then probably not. But if you made a small mistake, we try to write the questions so that you don't get tripped up by this sort of thing. We try to write the questions so that you get them right. Difference of 2 cubes. Yeah, we learnt it. Real firm off by continue next year. There's a question all about this in 2015. So rule for polynomials. And someone says, how was my strike? I spent most of my strike learning about polynomials. The VOD is on YouTube. If you want, you can watch. For art reasons, I recorded the whole thing. This was a bit of an error, but whatever. A wrong number, yeah, like carry forward wrong number, I think. Someone was asking about the real continuous version in the number file video. Yeah, are you the person there's someone in the comments who wants the thing to Google? I don't know. I just did a calculation on the back of an envelope or something, right? To say, so for reference, the thing we're doing here is you have maybe a die that spits out random numbers between 0 and 1. So it's kind of a really weird die. You press the button and it says, yeah, pi minus 3, dude. and you think that's a very strange number to have given me, and then you press it again and it says 0.5, and you think this is the weirdest random number generator in the universe. But it gives you numbers between 0 and 1. Then there's this version of the probability calculation you can do, which says that it's kind of a probability density function at this point, in a weird way, not in the normal way. I haven't really thought about it. But the thing that you want to do for that question with the repeated rolling is something like you want to do the integral like this. And then with like some really weird condition that there's some really weird condition over here that the p has to have kind of a delta function at the origin, which is not very convincing, I know, but hey. I did some scribbles on the back of an envelope. I found the continuous version, and then I put it in a number file video, and then everybody asked lots of questions in the comments. We will get there. We'll work it out. I think, what is it called? It's not a probability distribution function because it's describing the events that it's describing overlap. So it doesn't integrate to 1. It tends to 0.2. I genuinely don't know what to tell you. I'm sorry. Good luck. Yeah, I think this is the formalization you want. To be honest, I did things that felt intuitively correct to me, and it matched up with the numbers. So I thought, yeah, brilliant. My intuition is correct, and then just went with it. I haven't formally written this up. Maybe I should. Maybe I should write this up now that we're in a number file video with it. I'm gonna have to work out that I definitely mean this. This is super weird as well. No one's gonna like this. Oh yeah, Oscar and Anonymous are sharing polynomial facts, which also answers the homework. Oh, there you go. Look at that. You can always pull out a factor of x minus y. So when you see this, you see a minus b, and then go for it. And there's a rule on the screen now. You just add together with decreasing powers, like this. Brilliant. And so then the hard question, can you go further? Can you factorize again? What do you think, chat? Can you factorize this? I guess I should ask you if you can factorize. I mean, you can't factorize that. You definitely can't factorize a plus b. You can't factorize this quadratic. It's just discriminant stuff in the quadratic. Can you factorize this cubic? I think I've already missed the train. It's fine. I'll get the next train. There's many trains, which means a bit more maths. Probably shouldn't do any more math questions because people have, I think, left. I really want chat to do this one though. The last people to leave are getting extra maths questions. I've also lost the button that turns off the live stream. I don't know where it is. Oh yeah, other facts you can do x cubed plus y cubed. Correct, chat. I'd like a factor of this. Oscar says never tried factorizing this, so we've got a task to do now. We've pulled out a factor of a minus b. Are there any more factors we can put out? How am I live? Where am I live? Is there a video? Oh, I'm over here. That horrible feeling of realizing you're broadcasting live to like 40 people and you can't work out how to stop. I'm not going to stop until chat tells me another factor of that cubic. Gonna be here. Yeah, if I do the real value die, if I do this properly. So homework for me, homework for James, do this properly. Come on, chat, you can do it. There is a factor of this cubic, one that you stand a chance of getting. Yes, chat. Yes, chat. Yes, chat. Yeah, you spotted my trick. You spotted my trick. This thing on the left was difference of two squares all along. Did you see the squares? The squares are a squared and b squared. It was difference of two squares all along. And then that difference of two squares is also difference of two squares. You spotted my trick. Good stuff. Which means that by doing difference of two squares twice over here, aha, that means that this must be a plus b times something. Yeah, and it's a plus b times a squared plus b squared. And if you squint at it, you can kind of see like a squared times some stuff, b squared times some stuff. Oh, it's the same stuff. I like the difference. I like the difference of two squares. Cheeky, start again, pull out the factor you wanted to pull out, a squared minus b squared, and then factorize that again. Homework for you is a to the 8 minus b to the 8. Is it too obvious? Is it too obvious that I'm just being cheeky? Right, good. Let's get great. There we go. Excellent. Proof that I should stay live until chat does the question. Excellent. Don't do this one live. We're not doing this one live. Any point in getting into the BMO stage this year? Won't be in time for UCAS. It never is. It never is, and that's fine. That's fine. We're not asking people to do the BMO. Is there any point in doing it? Yeah, it's kind of fun. It's got hard maths questions on it. Sort of thing I like anyway. It's not for everyone. It's another exam at the end of the day, isn't it? And everybody needs more exams. Won't be in time for the UCAS deadline. You'll hate this, but I actually think people should keep doing math stuff after the UCAS deadline. But you can finally write your personal statement and stuff. But then after the UCAS deadline, I sort of hope that you like maths enough that you might want to keep doing some afterwards. Obviously at university, but maybe even in between. There we go. Welcome to chat, by the way. Glad this. Yeah, hi. Figured out the difference between two squares, so we'll say a plus b. Nice. So then the sneaky thing to do, if you don't want to spoil that that's how you did it, the sneaky thing would be to be like, oh yeah, I reckon I've spotted a factor on that cubic. You get to, if you wanted to impress your friends, you could pretend, oh yeah, I think I might have just factorized a cubic by looking at it. They won't know that you sneakily just did difference to two squares like 3 times in a row. Good, right, okay. I've run out of content. That's not true. There's loads more content we could be doing. I had a good attempt at that. All right, let's review my progress. I've got extra time now. I've missed a train. Review my only success. I think I did an okay job of trying to explain this with pink string. I reckon someone could take that home and build it correctly. Skipped all the rest of 6. 5, terrible job. I did a really bad job on 5. Including wimping out of doing the bit at the end there. That was terrible. 4, sad that we didn't do 3 or 4 really. 2, I think we did the kind of key elements, told a story about approximations, made it seem like the point to the thing. Didn't do the last part, but you know. Short questions, I decided to speed run the short questions. Not sure that was useful. I don't know. Let me know. Good. Other short questions are available. Should probably not have got this one so terribly wrong live, but hey, forces chat. Oscar sees LaTeX in chat. We tried a different one actually, which there's a different chat window we use sometimes, which lets me do LaTeX, but not you, which is like sort of the weirdest thing, right? So that felt mean after a while. So we're back in this one. Quick bit of 3. I can tell you the point of 3 if you like. So this is about degrees of freedom and degrees of a polynomial. If you've got a cubic, you can put the turning points wherever you like. There are just enough degrees of freedom in your cubic. Oh, I've done a mistake here by calling them A, B, C, and D. What am I going to call my cubic? There are enough degrees of freedom. There are enough degrees of freedom, 1, 2, 3, 4, loosely speaking, enough degrees of freedom in your cubic to stand a good chance of solving some equations to send the turning points through 2 given points. And this is an exercise you can try. To given 2 points, maybe your 2 favourite points, find a cubic that's got those as the turning points. I think you can usually get away with it. I'm trying to say usually and vague things to trick you into doing the maths. For degree 4, you've got 3 turning points. So A, B, C, D, E, F. You've got 3 turning points. But when you go to degree 4, you only get 1 extra coefficient. So you've got 5 coefficients, but now you've kind of got 6 parameters. So this feels kind of underdetermined in a way. Maybe you can't solve to have those 3 turning points wherever you want. That means that there is some relationship between them, which very hard question would be to try and work out that relationship between A, B, C, D, E, F such that they are the turning points of some fourth degree polynomial. The question actually works through some different cases to try and do some transformations to approach that question. In here, we're in the kind of sub case that B equals F. Just throughout this question, the Y values on these things are set to be equal, which simplifies the question a little bit. You still don't have full, although I know that removes a kind of condition, that it introduces an extra condition. Anyway, that doesn't mean you can always do it, I think. Maybe it does. No, there's some left-right symmetry. It's really good. So this is kind of the idea behind the question. I hope you can see the idea behind the question is kind of okay, but then actually kind of totally unrelated to what you actually do during the question. So there's a little bit of a challenge of a math question, really. That there might be some nice idea behind there, but I don't think you really learn the thing. You don't really learn a thing when you do this question. You get a little bit close maybe to understanding a thing about symmetries, but that's why it's talking about symmetry in the middle here. But I'm not sure you quite learn a thing. And at best, if you learn a thing, it'll be a fact about polynomials. So it's probably not interesting anyway. Tips for spotting the idea on the short questions. Struggle to see the idea they want you to have. Give yourself more chances to see it, and I mean see it literally. So if you start writing stuff down, so over here I started writing stuff down, like my first step was to change some cosines to sines. I don't really know what the plan is, and maybe I'm wrong, right? Maybe the plan is that I should be setting y equals to 0, like that anonymous person in chat wanted me to do. Give yourself more chances to see it by taking some step. Maybe you don't know where you're going to go next, but if you take a step, then maybe you'll have another idea, and you can take another step. And you don't have to see the whole thing. You don't have to see the whole idea at once. You can discover it in small bits, but often the only way to do that is to have a sequence of realizations, which for me at least, I just can't do unless I write down intermediate things. So to give you another example, over here, oh, I've deleted it. This is why I don't delete stuff. Around here somewhere, I was writing down stuff that I kind of wanted to be true, or writing down stuff that I knew to be true, hoping that looking at it again would show me it going somewhere. Odd and even functions are not actually on the MAT syllabus. We can define them. We can try to define them, and then if we introduce them in a question, then we might try and ask about them. But we don't expect you to know what they are on the way in. I'm aware that some people in chat know lots of fancy words and know lots of fancy mathematics. That's not supposed to be an advantage. So if you know about odd and even functions, then it's not supposed to actually give you an advantage. It's better to practice more recent papers than ones before 2018 because the syllabus was different, or not enough. If you want to know, for the ones before 2018, there's a lookup table. So on the MAT page, which I can no longer find. Can I find my own website? Impossible challenge. On the MAT page, the one with the coffee cup, there is a table where if you look at old papers, like from before 2018, they've all got notes. And the notes usually say something like, watch out, for question 1C, this question was written in terms of radians. So we wrote these so that if you're looking at those older questions, you can still use them. It just might say, this question uses the trapezium rule, and reading between the lines, it'd say, you don't need to know, you need to know it's trapezium rule. This is my favourite sort of notes to see, which says, this question's about the trapezium rule, we're fine. So if you want those notes, they're in the table on the mathematician's test page, mathematician's test page on the departmental website with the coffee cup, which is maybe where you found this. So, you know, one or the other. Cool, okay, I think I'm going to call it there. Thanks for watching. I have all the best over the next couple of weeks. I'm going to see you next week for the 2022 paper, which will be, I think, our last episode. So, I will see you in 165.5 hours. Yes. No, I can't do it. I just can't. The sign off is never quite there. We're still not done. I want to say something encouraging, right? Because I do worry that people are asking about stress and nerves and getting ready for exams and what time of day is it. I do feel that. I hope it goes. I hope this kind of next couple of weeks goes better than you think. The best thing you can do is give yourself breaks. Go easy on yourself. You can't force yourself to have ideas if you're not in the mood for having ideas. So don't overdo it. If possible, try and relish it. Try and enjoy seeing mathematics, because I think deep down you really like mathematics. I haven't read your personal statements yet, but probably your personal statement says that you like maths in some way. Maybe not those words, but in some sense says that you like mathematics. Please don't just do math questions for the next 2 weeks. I'm sure you've got other stuff going on in your life, maybe just other forms of mathematics. Yeah, I hope it doesn't take over too much. Right, good. Okay, that was the thing at the end, and I will see you next week. Bye.